Hello, in this video we're going to talk about the graph of tangent, and we're going to split that into 3 videos. First section, we're going to introduce the graph of tangent line. Okay, so let's do a quick reminder. In a unit circle, and then we have an angle theta. Remember that this is a unit circle, and at this point is x and y, and we know that sine theta is equals to y, cosine theta is equals to x, and tangent theta is equals to sine theta over cosine theta, which is y over x. Now, remember that in class we talked about, hey, the trick to memorize sine 13 degree, 45 degree. Actually it's from 0 degree, 13 degree, 45 degree, 60 degree, and 19 degree. Now, let's see how much do you retain this information. So we have 0, and then 60 degree, 13 degree, and then 45 degree, and 60 degree, and 19 degree. That's the value for theta, and then sine theta is going to equal to, if 0, we know the sine starting with a 0, and then it works up 1/2, and then square root of 2, and then square root of 3/2, and then 1. Where cosine is the opposite, starting from the highest point 1, and then work its way down, which is square root of 3 over 2, square root of 2 over 2, 1 over half, and then 0. Now, tangent is equals to sine over cosine. Now, let's do this. So tangent 0 degree gives us 0 over 1, which is 0. And then tangent 13 degree is 1/2 over square root of 3 over 2, which is square root of 3 over 3. You can do this calculation at home. And then the rest of it is going to be 0, square root of 3 over 3, 1, and then square root of 3. It works its way up. And what about this one? Well, when it's equal to 19 degree, it's equals to 1 over 0. That means this is going to go to the infinity, because this part is undefined. So that means when theta is equals to pi over 2, if you remember that from Math 141, this is going to become our asymptote. Okay, so let's take a look. What does the graph look like from decimals? So in decimal, when I type in y equals to tangent x, this is what it's going to look like. Let me zoom in. And this is the graph. It's starting with 0, and then it's going to be increasing until it hits what? The asymptote. Then it goes to infinity. Where's the asymptote again? Is very close to, actually it's pi over 2. Oh, let me do the step and then you can see it more clearly. See, at pi over 2, the graph going all the way up. And what does the period? Well, if you see that the midpoint to the another midpoint is pi, right? So that means the period is going to be pi. All right, now let me write this down. Here is our graph. With the asymptote at pi over 2. And then since it repeats every pi, because the period, as we observe on decimal, we notice that the period is equals to pi, and the asymptote is at pi over 2. That means what's the other asymptote? Well, that means you need to add another pi because they repeat every pi. So that means at 3 pi half, they get another asymptote, or you subtract them. So that means at negative pi over 2, you will have another asymptote. So the graph look like this way. We drove 2 periods. Now let's discuss more by observing. What do you see about this graph? Maybe I can draw it nicer. Okay, we found the asymptote, we found the period. What about the center of the graph? The center of the graph is, let's just pick one to talk about, is here of each graph. We got it at here, which is 0, 0. Or since they repeat every pi, so that could be also pi 0 or 2 pi 0 or negative pi 0 because they repeat every pi. And then what's next? Well, there's another thing that I want you to think about it is, before we think about the other thing, is the center. So the center of the graph also gives us the midline. So the midline for the basic tangent function is going to equal to the x-axis, which is y equals to 0, the x-axis. Okay, so another thing I want you to talk about is the midpoint. What is the midpoint? We talked about the center of the graph. Now, is the midpoint? Technically, it's not midpoint because the midpoint should be the center of the graph. The midpoint is the point in between the center and the asymptote. Okay, in this case, the center is 0, the asymptote is pi over 2. So that means the middle of it should be, let me do something, maybe pink, hot pink. So the middle should be, oops, I want the hot pink. Okay. This one. So it's a yellow. So the middle from 0 to pi over 2 should be what? Pi over 4, correct? So that means the midpoint of the center and the asymptote is pi over 2. So let's think about it. When theta is equal to pi over 2, tangent pi over 4, is equal to what? Well, tangent pi over 4 is in here, is equal to 1. So that means the midpoint would be in here, which is this one is pi over 4 and then 1. Okay, that's another thing that I want you to remember. The center is, the midpoint is pi over 4 and then 1. That is come from tangent pi over 4 is equal to 1. So that's all the important information from the basic tangent line. Now, let's talk about the sinusoidal function. In the basic general form of sinusoidal function is equal to a times sine or cosine bx minus c plus d. That gives you the amplitude, the phase shift, the period, and the midline. And for tangent function is similar. Tangent function, we have a times tangent bx minus c plus d. It just in this case, tangent is not a sinusoidal function. Sinusoidal function means they have to be continuous, and then the pattern is repeat, which means something has to be look like this one. It's called sinusoidal function, but tangent is not. As you see, tangent we show in the decimal is more like go up, and go up repeatedly. They are not continued. They discontinue at the asymptote. So that's why we don't call tangent a sinusoidal function. Anyway, then amplitude only works for sinusoidal function. Amplitude is the distance from the maximum point to the midpoint. But our A, we give them another name. It's called stretch factor or stretching factor. I'm going to explain more of this later. So A gives us the stretching factor, and I want you to remember that A is not an amplitude in a tangent function. Amplitude only used for sinusoidal function. Okay, now what is B? B is similar to the sinusoidal function, which is help us to find the period. Since the period, the basic tangent function, the period repeats every pi. Remember that for sine and cosine, they repeat every 2 pi. So the period is equal to 2 pi divided by B. But since tangent, they repeat every pi, so that means the period is going to be pi divided by absolute value of B. Quite similar compared to the sinusoidal function. Let me write this in here. So for sinusoidal function, the period t is equal to 2 pi divided by absolute value of B, because the period is every 2 pi. But for the tangent, the period is every pi. And next is the asymptote. How do we find the asymptote? Well, the asymptote is equal to pi divided by half of absolute value of B. So in this case, such as in our tangent, the basic function tangent, our B is equal to 1. So that gives us the asymptote is pi over 2, which is right in here, right? We just observed that from the decimal. And then the next part is, and then since the asymptote also repeats in every period, so that means the asymptote is going to be not just have one, we will have a many asymptote, such as pi over 2 at another period in the basic function. So in more general, our asymptote should be every time we add another period on top of it. So that means asymptote is not just equals to pi over absolute value of B. Also, you will find another asymptote if you add the period, which is pi over B, or you add 2 periods or add 3 periods. So that means as k times the period. K could be any integer, which is 1, 2, 3, 4, 5. So similar in here, as you can see, our asymptote is pi over 2, and then the next one is going to add a period, which is pi over 2 add the pi, gives you 3 pi over 2. Or you can subtract 1 period, which gives you what? Negative pi over 2. Or you can add 10 pi, which is at 10 period, then you can find another asymptote 10 periods away from the first asymptote. Okay, domain. So what would be the domain of a tangent function? So the domain should be every x value, which is everything, except for the asymptote. So let me write the shorthand, write it. asymptote is ASYM. So that's my shorthanded for asymptote. And then range is all the possible value for y. So y goes to negative infinity to infinity. That means it's everything, which gives you from negative infinity to infinity. Okay. And also one more thing is tangent is an odd function. What is the odd function? That means negative tangent x going to equals to tangent of negative x. They're going to be symmetric over the center of the graph. In our case, would be the origin 0, 0. Okay, let's do one exercise. Now, I want you to sketch 2 periods of y equals to 0.5 tangent pi over 2x. I want you to pause the video and try to do it by yourself and come back. Okay, now we can check the answer together. So first of all, we have a equals to 0.5, b equals to pi over 2, c equals to 0, d also equals to 0. D equals to 0 tells us that the midline will mean y equals to 0. C equals to 0 means there is no phase shift. Okay, A equals to 0.5, that gives us what? There's a stretching factor involving in this graph, which is A equals to 0.5. That means they're going to stretch 0.5. I'll explain it to you what does that mean later. And then b equals to pi over 2, which gives you the period. The period is equals to pi divided by absolute value of b. So divide them, it got 2. So the period is equals to 2. And then we're also missing one thing, is the asymptote. So asymptote is equals to pi over 2 times absolute value of b, which is pi over 2, which is equals to 1. So that means the asymptote is at 1. Or you add another period to it, which is 3, or add another period, add 2 periods into it, which gives you a 5, or you subtract them, -1, or x equals to -3. Either one. Alright, since there's no shift on the phase shift, so that means the center of the graph will remain 0 and 0. Alright, now let's try it. We got to label everything that we know. I got this y, x, and this is 1, 2, 3, 4, 5, 1, -3. And we know that the center remains the same. And then we have asymptote at x equals to 1 or -1. Also at 3. And the graph, since the midline didn't change, there was no vertical shift. And we already labeled the asymptote, and the center, there is no phase shift or the vertical shift, so they remain the same. So the graph should look like something like that. Now, we need to label the midpoint. Do you remember the midpoint? What is the midpoint? The midpoint is the middle between the center of the graph, which is 0, 0, and the asymptote, which is when it equals to 1/2, which is when it's equals to 1/2, we have our midpoint in here. Let's see, we haven't used the subtraction factor now. Now it's going to use the subtraction factor. For the basic tangent function, our midpoint is equal to what? Pi over 4, 1. Midpoint is in the middle, which is the middle of the center, or half of the between the center to the first asymptote. In our case, is 1/2. We found the x-coordinate. So what about the y-coordinate? Well, think about it. We know that the tangent of the middle should equal to 1, right? But right now, we have to times 0.5. What happens if you times 0.5 on both sides of the function? Then your y-coordinate is going to become 0.5. So that's what happened to the subtraction factor. So that means the midpoint is 1/2 and the 0.5. So that gives them a stretch. That's how you notice the stretch. Okay, so that's the graph for this equation. Now, when it comes to the graph, what I'm looking at is, I hope you to graph 1, the asymptote. 2, I want you to graph the midpoint and the center of the graph, because that shows you the midline. 3, also the midline. Okay, but are we done in here? The answer is no, because the question is asking you to graph 2 periods of this function. So that means you need to make another one. Repeat. Is from here to here. So you still need to label everything. So that means our midpoint is going to become 1.5 and then still the same at 0.5 because of the subtraction factor. We use 1 times a. Okay, that's it for this section. Let me know if you have any questions.